Have you ever looked at the night sky and wondered about the stars? How they shine, what they're made of, why they exist at all? These are big questions, the kind that humans have asked for millennia. But what if I told you that to understand the universe's biggest mysteries, we need to look at its smallest pieces? This is where quantum mechanics comes in. It's the science of the very, very small atoms, electrons, photons, the fundamental building blocks of everything around us. And trust me, things get weird down there. Quantum mechanics isn't just some abstract theory, it's the foundation for many technologies we use every day, from lasers and smartphones to medical imaging. Understanding it is like getting a peek behind the curtain of reality itself. So are you ready for a journey into the quantum world? Buckle up, because things are about to get very strange, very interesting, and very illuminating. Imagine a basketball game. You know the rules. The ball moves in a predictable arc when thrown, players run on the court, and points are scored. The game is straightforward, governed by clear and consistent rules. This is how we experience the world in our everyday lives, governed by the laws of classical physics. Everything follows a predictable pattern. Now shrink yourself down to the size of an atom. Imagine diving into a world so small it's almost unimaginable. Suddenly, the rules of the game change completely. The familiar laws no longer apply. Welcome to the quantum realm, a place where the bizarre becomes the norm. Here, things don't behave as neatly. The predictable patterns of the macro world vanish. Particles can be in multiple places at once, defying our everyday logic. They act like waves and particles simultaneously, a duality that challenges our understanding, and even influence each other instantly across vast distances. This phenomenon is known as quantum entanglement. It's like the basketball is now teleporting around the court, appearing and disappearing unpredictably. The players are blurring in and out of existence, as if they are phasing through different dimensions. And the scoreboard is showing multiple scores at the same time. Confusing? Absolutely. But also incredibly fascinating. This is the essence of quantum mechanics, a set of rules governing the universe at its most fundamental level, where things are fuzzy, uncertain, and full of mind-bending possibilities. It's a world that challenges our perceptions and expands our understanding of reality. Let's dive into one of the most famous and mind-boggling experiments in quantum mechanics, the double-slit experiment. This experiment has puzzled and fascinated scientists for decades. Imagine shining a beam of light at a wall with two narrow slits cut into it. What do you think will happen when the light passes through these slits? You'd expect to see two bright lines on the back wall, right? This is because the light would pass through the slits and create two distinct patterns. Well, that's exactly what happens with normal light. The light waves pass through the slits and form two bright lines on the screen behind. But when we use tiny particles like electrons instead of light, something truly amazing and unexpected occurs. Instead of seeing just two lines, we observe an interference pattern, a series of bright and dark bands. It's as if the electrons are behaving like waves and interfering with themselves. But here's the real kicker. This interference pattern appears even when we shoot the electrons one at a time. It's as if each electron somehow goes through both slits simultaneously, exhibiting wave-particle duality. And if that wasn't strange enough, when we try to observe which slit an electron goes through, the interference pattern disappears completely. Instead, we see two distinct lines again, as if the electrons are behaving like particles. This experiment highlights a key principle of quantum mechanics. The act of observation affects reality. The mere act of measuring or observing changes the outcome. The very act of measuring or observing a quantum system influences its behavior in a fundamental way, collapsing its wave function into a definite state. It's as if the universe chooses a definite state only when we look at it, collapsing all possibilities into one reality. This is the mysterious and fascinating world of quantum mechanics. Imagine two coins flipped at the same time, one landing on heads and the other on tails. Now imagine these coins separated by a vast distance, say, the Earth and the Moon. Would knowing the outcome of one coin flip instantly tell you the outcome of the other? Of course not. In our everyday world, this seems impossible. However, in the quantum world, particles can be linked in a bizarre way called entanglement. When two particles are entangled, they become connected, no matter how far apart they are. This connection is so strong that measuring the state of one particle instantly determines the state of the other, even if they're light years away. This phenomenon defies our classical understanding of physics. Einstein famously called this spooky action at a distance because it seemed to violate the fundamental rule that nothing can travel faster than light. He was skeptical of this idea, yet numerous experiments have confirmed the reality of entanglement, suggesting a deep interconnectedness in the universe that we are only beginning to understand. This interconnectedness hints at a more profound layer of reality. Entanglement isn't just a theoretical curiosity. It has profound implications for developing new technologies like quantum computers and ultra-secure communication networks. These advancements could revolutionize the way we process information and communicate. One of the most intriguing thought experiments in quantum mechanics is Schrödinger's cat. Imagine a cat sealed inside a box with a device that has a 50% chance of releasing a lethal poison. Until we open the box, we have no way of knowing if the cat is alive or dead. According to quantum mechanics, the cat exists in a superposition of states, both alive and dead, until we make an observation. It's only when we open the box and look inside that the cat's fate is decided. This thought experiment highlights the mind-boggling concept of superposition, where quantum systems can exist in multiple states simultaneously until a measurement is made. It challenges our classical intuition about how the world works and forces us to rethink the nature of reality itself. Of course, no actual cats are harmed in this thought experiment. It's merely a way to illustrate the strange and counterintuitive nature of quantum mechanics. Section 6. Through the looking glass, quantum tunneling. Imagine throwing a tennis ball at a wall. You expect it to bounce back, right? That's because in the macroscopic world, objects don't simply pass through solid barriers. But in the quantum realm, things aren't so clear-cut. Quantum tunneling is a phenomenon where particles can pass through seemingly impenetrable barriers. It's as if the tennis ball suddenly vanished in front of the wall and reappeared on the other side. This mind-bending effect is possible because particles behave like waves in quantum mechanics. Just as a sound wave can travel through a wall, a particle's wave function can extend through a barrier, giving it a small but finite probability of tunneling through. Quantum tunneling isn't just a theoretical curiosity, it plays a crucial role in various technologies, including transistors, flash memory, and even the nuclear fusion that powers our sun. Section 7. Quantum mechanics in your pocket. You might be thinking this is all very fascinating, but how does quantum mechanics affect my life? The truth is, it affects us in countless ways, even if we don't realize it. Remember those lasers we mentioned earlier? They rely on the quantum properties of light to function. And what about your smartphone? The transistors that power it wouldn't exist without our understanding of quantum mechanics. Medical imaging techniques like MRI scans rely on the quantum properties of atomic nuclei to create detailed images of the human body. Global positioning systems, or GPS, rely on atomic clocks, which use the precise frequencies of atomic transitions to provide accurate timekeeping. These are just a few examples of how quantum mechanics has revolutionized our world. And as we delve deeper into the quantum realm, we can expect even more groundbreaking technologies to emerge. Section 8. The future is quantum. The future of technology is deeply intertwined with our understanding of quantum mechanics. Quantum computers, for example, promise to revolutionize fields like medicine, material science, and artificial intelligence. Unlike classical computers that store information as bits, zeros and ones, quantum computers use qubits, which can exist in a superposition of states, allowing them to perform calculations exponentially faster. Quantum communication networks promise ultra-secure communication channels, virtually unhackable due to the principles of quantum mechanics. Quantum sensors offer unprecedented sensitivity for applications ranging from medical diagnostics to environmental monitoring. As we continue to explore and harness the bizarre and wonderful world of quantum mechanics, we can expect a future filled with technological marvels that were once considered science fiction. Section 9. A final thought. Quantum mechanics may seem strange and counterintuitive, but it's a testament to the boundless wonders of the universe. It reminds us that reality is far more mysterious and awe-inspiring than our everyday experiences might suggest. So, the next time you look at a star, use your smartphone, or undergo a medical scan, Remember the invisible quantum world that makes it all possible. It's a world full of mind-bending phenomena, profound implications, and limitless possibilities. And who knows what other secrets of the quantum realm we have yet to unlock?